Good evening, everyone. Uh, so today we are going to step into the data mining and analytics world. A brief introduction is here with me. And without any delays, let's move on to the presentation. Uh, right. It is essential to understanding the hierarchy of the data, information, knowledge, and what is intelligent. Actually, the data is the raw input. Like imagine numbers on a spreadsheet without any labels. Alone, data has no meaning. Then comes the information. When the data given a context, it becomes information. For an example, if previously mentioned numbers in the Excel are labeled as temperature and city, and now we understand what they represent, so that is information. And next comes the knowledge. When we analyze the information to spot patterns, we found knowledge. For instance, discovering the coastal cities constantly having mild temperatures, that insight is knowledge. Next one is the intelligence. Um, Intelligence is the ability to make decisions and predictions based on the knowledge we gain from the information. For example, recommending beach destination based on weather trends, that is intelligence. So this hierarchy is crucial, and it transforms simple records into business strategies, medical decisions, and predictive analytics and things. And let's move on to the next slide. When we talk about data, big data, it is we are not just talking about a lot of data, right? We are talking about the complex data environments, and we need to understand what are the characteristics of big data. Essentially, there are four characteristics of big data: volume, velocity, variety, and veracity. When you talk about volume, it's this property is about size, right? Facebook generates over 500 terabytes of data every day. Next one is velocity. Velocity means data is generated at lightning speed. For an example, think stock markets. They produce millions of data points per second. Next one is variety. When it comes to data, data has many forms, right? Images, videos, numbers, and many types of data, many formats of data. That is variety. And veracity means when we come to big data, not all the data are accurate, right? They are not reliable. Sensors can malfunction, and users might given false information. That is why cleaning and verifying data is so important. Understanding these four V's, we call this four V's, and helps us to build systems that can handle real world challenges. Right. Let's move on to the next slide. So before we can use data, we need to make sure it's clean and complete, right? So let's say we have a customer data set and some entries are missing. Maybe few don't have things like this. Few don't have age listed. Their age is not in the data set. So what we do? Only few records, right? So there are several things we can do, like identify. First, we have to do is identify the missing values. We have to locate the gaps, and one of the options is deletions. If only a few records are incomplete, we can remove them. But doing that, we risk losing valuable data. Then comes the imputations. Means fill in the values. For imputation fillings, we can use 2 to 3 methods as mentioned here. Mean imputation, we can replace the missing values with the average, and regression imputation, we predict the missing values using other variables. For example, think like this. If we know someone's income and their occupation, we might predict their age, right? These setups ensure that we don't feed garbage into our models, right? Because it's essential to remember that dirty data means bad predictions, right? So here mentioned a technique called binning, right? Sometimes continuous data can be too detailed. For example, imagine analyzing customer ages from like 21, 22, 23, and all the way up to 80. Uh, these data too continuous, right? So think if we have missing values in some range, and if we use mean to replace that, maybe that is not correct, right? So we can use binning technique. Rather looking at the every single value, we are using binning to group them. For example, 0 to 18, we can think children, 19 to 35, young adults, and 51 plus people are seniors. So if we think, for example, if a age record is missing on 0 to 18 ages, we can take the mean of that category and replace the value in there. So it will be more accurate than replacing whole median value in all places. There's another thing we can do that is not mentioned here. We can add a global constant like unknown or something. It is also not recommended. And let's move to the next slide. Right. So, right. So when we working with text data, right, like tweets, emails, reviews, we need to turn it into a format that machine can analyze. So here is a standard text pre-processing pipeline. First, we do is tokenization. Tokenization means simply split sentence into words. As an example, think the quick brown fox. We can split them into the quick brown fox like that. This is tokenization. So we can next thing we can do is to eliminate the common words that carry little meaning, like is, the, and those things we can remove. Then comes two major parts like lemmatization and stemming. Those two techniques, they reduce the words into their root forms. Like when we talk about stemming, it reduces the word running, ran, runs into its root form, run. So in lemmatization, it is far more better. It changes to its dictionary meaning. For example, if we take the word better, it converted to good. This is lemmatization. And this clean text is now ready for feature extraction using techniques like TF-IDF value. We are going to talk about in next slide. So moving forward, one of the most powerful technique to identify important words is TF-IDF value. So let's break it down to understand more better. TF value means term frequency value that tells us how often a word appears in a document, right? For example, in the sentence, you can see the cat sat on the mat. The word cat appears once out of 6 words, right? In the first document. So its TF value, we can give 1 divided by 6. It's nearly 0.167. And next one is IDF value. IDF value means inverse document frequency. It checks how rare a word is across all documents, right? As an example, if cat appears in every document, IDF value will be 0. So for an example, think like this. If a word is frequent in one document, right? If a word frequent in one document but rare across others, it gets a high score. That means it has a high value. If a document, a word is frequent in a document and across words like the things, it is not given a high score because it is less meaningful to our use. So This method, TF-IDF value method, is used widely in search engines, spam detections, and document classifications. And right, next one is term similarity methods. So once we have numerical values for text, we can compare them, right? There are two popular methods we can compare words, text. So first one is cosine similarity. It calculates the angle between two vectors, two documents, right? Think there are two documents. If they are very similar to each other, the angle is small. So the similarity score is coming closer to 1, right? If they are different, example, let me tell an example forward. If they are different, angle is large, right? If there are documents are different, the angle will be large. So similarity approaches to 0. For an example, machine learning is cool and AI is machine learning. Those two documents will have high similarity in cosine similarity. So next, let's talk about word embeddings. So word embedding is a technique which maps words into high dimensional spaces, right? So high dimensional spaces mean there are maybe 100, 500,000 to 25, 24 plus dimensions in modern models like vector dimension models, word embedding models. So in embeddings, we can place similar words closer. Like example, king, man will be somewhat closer, right? So semantic relationship also we can capture here, as you see on the screen. If we subtract man vector from the king and add that woman vector to it, it will be partially equal to queen. And if we get cat and dog vectors, they will be very close, right? This is word embeddings. And let's move on to the next one. So next one is classification. So classification is a supervised learning task, which means we teach the model using labeled data, right? So let's take spam detection as an example. You can see on the screen. So emails are converted to numeric vectors using TF-IDF method. So then we use Bayes method to learn which patterns are linked to spam and not spam. So as you see on the screen, think a new email, free pizza at meeting is coming, then we can calculate the spam probability and not spam probability from there. Whichever the probability is higher, it becomes the prediction. Uh, so this is how Gmail spam filter works. And in here, there is a yeah, this is the example. And let's move on to the next one. Right, clustering. So unlike classification, clustering doesn't use labels. This means this is unsupervised learning. We let the model to find natural groupings in the data. We don't give labels. We let them to find the natural groupings. So in here, clustering, there are several use cases like customer segmentation. We can group customers by their behavior, and document clustering. We can document grouping similar articles, anomaly detection, like finding unusual patterns like frauds. So as you see on the screen, there is a simple k-mean example. So you can see that customer 1 is 25 years old and 30,000 income, and customer 2, 3, and up to 6, there are 6 customers. So using k-mean, right, divided into k-means is a popular algorithm we use to use for clustering. We can define k-means. We can use k-mean and divide the group into 2. Then the first cluster will be young lower income cluster. As you see on the screen, 25, 30,000 income, 30, 35,000 income. 28, 32K income, and second will be all the higher cluster. So other than K-mean, there are more common algorithms like hierarchical K-mean and DB scan are some of them. Let's move on to the next one. So next one is association rule mining, right? So this techniques helps us to find patterns like if X happen, if X event happen, then Y also tend to happen. Right. For example, in supermarket things, 60% of shoppers buy bread and butter, and there are some rules like 80% of those who buy bread also buy butter. Like these examples, as you see on the screen, in a priori algorithm is a common algorithm we use to association rule mining. First, in here we find frequent 1 minus item set, means like in here we are getting single item above a supported threshold, right? And we generate from that, we pair them, and again we calculate their support, and if it is about threshold, we get it, and like that we continue with no until there's no more frequent sets. And for in this part, there are several key terms, right? It's essential to know those key terms. When we come to the a priori or associated rule mining algorithm, there's a support thing called support. The support means how frequently the combination of items appears in the data set. For an example, right side example, you can see that there are several transactions. So analysis report say that there's a rule: if someone buy bread, they are tend to buy milk. So their support is like 40%. This means there are 5 transactions, and 40% of them support our theory that bread and milk will be bought together. And their confidence is calculated by confidence means that tells us how often bought milk is bought when bread is bought. And lift is like compares the observed confidence of a rule to the expected confidence. Think like so so this is the basic association rule mining. And when we talk about the common use of this real world use, we can use this for market basket analysis, and we can use this for dynamic store layouts. There's a common rule that the people who buy beer and bread are tend to buy diapers. So store layouts are layouted that sometimes you also see that some layouts are there that not like bread and milk are kept next to diapers. It doesn't make sense. No, these things are used in real world examples. And so right, for at the conclusion, so we have explored key data mining techniques very briefly, from pre-processing to advanced analytical tasks. So there's always more to discover and explore, like the topics specialized in these things. So right, that's it for the presentation. And just remember that clean data plus smart algorithms is always valuable decisions. And right, thank you for your attention. Thank you for listening.